right. So we were doing some stuff. We're doing some synthetic division. And we're gonna do a little bit more with it today. Maybe I could start with, this is math 35. Welcome back, everybody. Your tests are not graded yet. I'm still waiting on a couple of makeup exams. They will be graded. I'll send out an announcement when the grades are posted. They'll be posted on Canvas, and you'll be able to pick them up and look at them and see what you did wrong when they're ready. Don't worry, you already know if you did all right or not. You know if you walked out feeling confident or not. Today we're going to be doing, and we're going to do a little bit more with 3.2. We're going to do 3.3 and some of 3.4. 3.2 was on synthetic division. Let's see, what do I want to do here? Let's go with let's see. So the way we did synthetic division is we take the coefficients of this up here, the coefficients go in here. About 1, -8, and 12. And for what we have out here, we set this equal to 0. We solve it, we get x equals 2. That's what goes here. No one's telling me I'm off the fucking screen. Thanks, guys. Appreciate that.
I mean, you can see it.
God damn, where the fuck is everyone?
It's all true.
I know Eric did well. I'm sure he did well. I remember he was doing well on everything in class he did well on. Every question he had answers for, he was never afraid to answer. Wasn't chicken shit. No. Nothing wrong with that. But he's not here, so he's not here for some other reason. There's a lot of people online. Hi, fucking people like, there's 7 motherfuckers online. Hi, folks. That's where everybody is. They're over there on Zoom. Hi, guys. Xavier's in fucking bed. That's fucking great. What?
So is that one of them?
Is who? Ah. Let's see the whole list. I gotta scroll down the names. Eric is not one of them. All right, where was I? All right, so synthetic division. Skip class for fucking Monday Night Football. Doesn't even start really till after 6, does it?
5:15.
You ain't missing nothing if you miss the first 45 minutes. That's nothing. Bring the first number down. You take this number, you multiply it, and you got that right there. You add these two together. You multiply them. You add these two together, and we get 0. And our end result is a polynomial of 1 degree lower. Here's the outcome. And these are the coefficients. Coefficients and remainder. The last one is the remainder. So I have a positive 1 and a negative 6. We started off with x squared. So 1 degree lower, it would be x to the first power. So that's what I'm doing right here, finding 1 degree lower. So we'll put in x to the first power with that one. This is an x to the 0, but x to the 0 is just 1. This ends up being x minus 6. So the results, if I say f of x is x squared minus 8x plus 12, and I divide both sides by x minus 2, this is effectively what I'm doing. I get x minus 6 left over. And I'm going to write it even though it's a 0 because I want to point out that, because this is important, plus a remainder of 0 from there. If f of x equals x squared minus 8x plus 12, what does it factor into?
X minus 4, x minus 4.
That was worth a try. It's a very good try. Not quite. X minus 4, x minus 4. If we had did negative 4 times negative 4, we would have a 16 at the end.
Minus x minus.
Minus 6 and minus 2. Of course, you could have seen that had you just cleared fractions right here. Similar with this. So I got a remainder of 0 on that one. Let's do this for a few others. You go ahead and do synthetic division with x squared minus 8x plus 12. And do, for the bottom, try x minus 1, x minus 4, x minus 6, x minus 8. It doesn't take that long to do the synthetic division. I'll put that up there right there. You're just multiplying and adding.
Do those.
Yeah, do those four. We're showing something.
Can I see the little page? No. Yeah, that one. Thank you.
You still need that up? Are you good?
Oh, I still need it. Let me take a picture.
No, go ahead.
Oh,
See if I can bring this down. I can bring down the synthetic division so people can see it while they're doing it.
I'm done. Thank you.
There's a method to my madness. If I make you do this by hand a few times, you'll have synthetic division down a little bit better. The box hasn't changed. It's gonna be 1, -8, and 2, 12 for all of them. You're just basically doing the opposite sign on the outside. All right. Let's go through it pretty quick. Each of them we bring down to 1. Values different colors so they stand out a little bit better. 1 times 1 is 1, -8 plus 1 is -7. 1 times -7 is -7, and out of that we get 5. So this would have an x minus 7 plus 5 over x minus 1 when we divide it.
The first one, you got a -1.
What?
The first one, the -1, it's the x -1.
Oh, yeah. That changed shit, doesn't it? Because of the 3. Good catch. That was me being. Wait, why? Why?
No,
No.
it was right. It
I
was
had it right. You're fucking with me.
right.
Oh, the left side you put x negative one.
Cause we have to solve this for 0,
Okay,
just like we did up here.
okay.
Got Jedi mind trick. So what we did was this, and we got x minus 7 plus 5 over x minus 1. We do this here, we got a 4, we got -4, -16, we got a -4, so x squared minus 8x plus 12 over x minus 4 equals x minus 4. I'm gonna say plus -4 over x minus 4. This is how synthetic division works. These are the results. Get a 6 up here, that's a -2, -12, and a 0. This is x minus 2 with no remainder. If I do this here, and we already saw, I'm gonna put this back up here. So we're gonna say f of x equals x squared minus 8x plus 12. What is f of 1?
Like you mentioned, so we're just like.
Just evaluate it. What's the final result? Plug it in. Let's find out. We've got 1 minus 8, 1 plus 12 is 13, minus 8 is 5. I put in 2. 2 squared minus 8 times 2 plus 12. That's 4, that's 12 is 16. 16 minus 16 is 0. I put in 4. I get 16. Plus 12 is 28. Minus 32 is -4. When I did f of 1, I had a 5. When I did f of 2, I had a 0. We saw that on the other page. When I do f of 4, I get a -4. What do you think I get when I do f of 6 and f of 8? 0 and 12. That's really fucking neat, right? Which name is this thing fucking called? So this is called the remainder theorem. If f of x is divided by x minus k with synthetic division, the remainder equals f of k. And we saw when the remainder equals 0, shows we had divided by a factor. The only two ones we got zeros on were 2 and 6. When we look at these, the only two we got 0 on were 2 and 6. And we already know that x squared minus 8x plus 12 equaled x minus 6, x plus x minus 2. So if we set that equal to 0, we get x equals 2 or x equals 6. So this is like if I call this k, k1 and k2. If f of x over x minus k something equals 0, x minus k something is a factor of f of x. It reveals the factors. And if you plotted this to connect this with let me do connect this with what we did in 3.1. X squared minus 8x plus 12. We had the vertex is hk, where that's negative b over 2a and f of negative b over 2a. H is negative 8 over 2 times 1, which is 4. And I think we already did 4. Actually did 4. Fuck yeah, sweet. And we saw f of 4 was negative 4. So
Can you go a little bit up to take a picture, please? Sorry, sometimes I'm slow and you did it too fast.
I'm going too fast, just say so, and that's fine. I'll slow down, I'll stop.
I have a question.
Yeah.
I have no idea what you're doing on the last page.
Okay, so are you okay with this being the factors are x minus 6 and x minus 2?
Yeah, can you go to the last page?
This page here?
Yeah, yes. So I see what you did with the chart, but I don't understand like how you're putting it together. Like what rule is it to put together? Like when you put x minus 7 plus 5 over x minus 1. You know what I mean?
Okay, so I am taking these things right here. And whatever degree I started with a 2. I start with 1 lower here.
Mm-hmm.
And and I go downward. X0 is just 1, so we don't do that. We just leave that one off. Whatever the last one is, you put over the old denominator.
Oh, okay. I see.
Does that make sense?
Mhm.
Did I not cover that well in the last class? I thought we did that.
I missed the last class.
Oh, okay. That explains it.
Okay.
All right. Does that make sense? You see what, like here, we divided in 8.
Yes.
I got 12 over x minus 8, and there was a 0 here. Okay. Let me know when you're done with this one, Josue.
I'm done.
Other people are still writing. No, people don't look like they're writing. All right. So that's what we had. I'm gonna wrap this for a second. I'm connecting this to what we did in 3.1. So my vertex is at H is 4, down 4. And when A equals 1, the coefficient is 1, we can go left 1, right 1. And then left 2, up 4. And right 2, up 4. So the pattern is left and right 1, up 1 times A. Where whatever A is, whatever's in front of x squared. Left or right 2, up 4 times A. Like the square of this number, square it. And multiply it by A, because that's what's on the outside. And then you can do left or right 3, up 9 times A. Where A is with the AX squared kind of thing. All right, so I'm connecting that with what we did there. We got our vertex here. That is 2, 0. And that is 6, 0. So doing f of k equals 0 shows you the x-intercepts. At x equals k. And this stems from y equaling f of x. And when we want an x-intercept, y equals 0. So f of x equals 0. So if we find where those all equal 0, that's how we get it. These are called, when you get these x equals k, they're called zeros of f of x. Because it gives you a 0. They're also called roots of f of x. Not sure where that terminology comes from. And they're also called solutions. They give them a bunch of names because they like that shit. is x minus 1, a 0 of f of x equals x cubed minus 1.
You can go up a little bit. Just a little bit up.
That's the top of the page.
That's it.
Going up anymore ain't gonna help you. Oh, hell no, no whistling. None of that shit.
X cubed minus 1.
It is x cubed minus 1. So the quick way of checking it is set this equal to 0. And we get x equals 1. And so you can see if it's a 0 by finding out, does this equal 0? F of x equals x cubed minus 1. We do f of 1, we have 1 cubed minus 1. It does equal 0, so yes. Synthetic division will show us the other factor. So x minus 1 equals 0. That gives you x equals 1 is a 0. So let's do x cubed minus 1 divided by x minus 1. And the reason why I bring this up is I want to show you what happens when we skip stuff. This is the same thing as x cubed plus 0x squared plus 0x to the first power minus 1. Does that make sense? You're like, why the fuck are we throwing in zeros? Because when you do this synthetic division, you have to have those zeros in there. So if a term is missing for synthetic division, use 0 in synth dev. So Hannah, since you're the one that asked, and I know you feel that you've got this down, what x power do I put here for this one?
2, 0.
What?
What? Oh, we started with 3, so 2
2, yeah. And this one,
to 1.
which we wouldn't even put, and then we got that. We've got a remainder of 0, so we don't even need to write it. This equals x squared plus x plus 1. And you could have found this another way. This was the difference of cubes. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. I just stole from that real quick. The real reason main reason I want to do it. What?
Can you go a little bit up? little bit up. Little push. Yeah. Okay, that's fine.
That's like the whole fucking page, Josue. What were you
Sorry,
doing
this-
the last 6 minutes?
That's because like I'm doing it in digital tablet, so sometimes it fails and I just get get behind.
Okay.
Sorry about that.
It happens. My Surface Pro, I don't like using it for that very reason. I write some shit and like some of the shit doesn't show up clearly.
Don't worry, I will be taking all the classes with you.
Are you threatening me? Oh, like a fucking threat.
First, it was the disappearing of you.
Alright, so. Do you need that part up longer? Is
No,
everyone
no,
good?
that's the one I took a picture. That's fine. That's fine.
Huh. Oh. What about, oh, you're gonna love this. Is k equals 1 plus 3i a 0? Oh, this motherfucker gonna bring complex numbers into synthetic division? What kind of piece of shit does that? Hefe does that. Hefe brings the pain. So we're gonna be doing complex numbers on our synthetic division. I recommend giving yourself some space on these coefficients. Add these up, I get 0 plus 3i or just 3i. And now you might want to do the rest of this shit down below as you do it. 1 plus 3i times 3i, we gotta multiply this to put it up here. This is 3i plus 9i squared. But I squared is -1. So this is -9 plus 3i.
Yeah, it's a -9.
3 times 3 is 9 and I squared is -1. So 9 times -1 is. All this shit was on, the questions like this, one of them was on midterm. So. Sounds like Luis may not have fucking like that question. Alright, so we add those up, what do we get? -3 plus 3i. So now we get to do this with 3 plus 3i. Times what we had out front, 1 plus 3i. -3 minus 9i. Plus 3i. Plus 9i squared. So this is -3 minus 6i. This is again -9. So minus 12 minus 6i. And I add those up, I get 2 minus 6i. We're almost done. Multiplying it out. What?
This year.
Actually, what?
It actually is underneath years ago.
As a remainder 0. This is negative 18 times negative 1, so positive 18 there. I got 2 plus 18, and these cancel out. That's a 20. 20, it gives us a 0. So x equals 1 plus 3i is a root. This kind of leads us to our conjugate theorem. If a plus bi is a 0 or a root, so is its conjugate. And what is the conjugate of a plus bi? Anybody remember? What's the conjugate of a plus bi? A minus bi. We went over this in fucking complex numbers.
Did we?
Yeah. Fucking, you kept playing footsies with fucking Darian and got distracted. You know, this is kind of shitty. Because this one up here is gonna lead to x cubed plus 3ix squared plus negative 3 plus 3ix plus 2 minus 6i as what's left. Because it's got to go down a power, and these are the coefficients. But if you divide this, 1 plus 3i went in, so 1 minus 3i will also be a root. And yeah, and when you're done, if you do 1 back to back, you're back to whole numbers again. Well, integers on the bottom. Because complex numbers come in pairs.
We're gonna take a break.
Sure, why not? Let's do it. Let's take a break. That's a good call.
Okay,
I'm glad you asked.
I will get the chance to do to get this when you can go a little bit up. Sorry about that.
All right. So we talked about the conjugate, yeah. you're not gonna like this one. Because most of the stuff you've done has led to having factors that were whole numbers, it's working with stuff like that. The rational zeros theorem. Sometimes when we have x equals k, k is really a rational number. In the form P over Q. And we'll assume it's written in its lowest form. Assuming P over Q has been simplified. If f of P over Q equals 0. So it's like a 0 of f. Then P is a factor of the constant term. And Q is a factor of the leading term. Let's do one you already know the answer to,
Why don't you put masters in front?
so they'd stand out. Constant term. Leading term. So what are factors of P? Factors of 12. Say them again. 8 is not a factor of 12. 2 is a factor of 12. 4 is a factor of 12. 6 is a factor of 12. You keep going crazy. There are 2 more. There's several more actually. I might say 2 more. There's more more fucking 2 more. You missed the 3. 1 does count. 1's got to go with 12. What? Does 5 go into it? 6, you're at the halfway point. Once you get to the halfway point, you don't have to check anymore. So P can be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. It can be positive or negatives. Q has factors of 1. This is easy. What makes up Q? Plus or minus 1? So the only possible rational zeros are of P over Q. In this case, it just happens to be P. And we found them. It was 2 and 6. We'll pick it up in a second.
Why did you put the plus 2 and plus 6 in the mind?
Why did I do what?
The plus 2 and plus 6.
These are the two that worked. We solved this already.
That was for the very beginning.
Yeah.
Oh. Like wait was, yeah.
Actual zeros. That one's a little easier because there's easier ways to do it. But I wanted to show that the premise still holds. How's Sway? Are you done?
Yeah, I'm done.
Let's go to one that's not so easy.
So
I think make it look a little bit better. So our P set comes from the 4, which is plus or minus 1, 2, or 4. The Q set comes from our 8. 1, 2, 4, and 8. This helps to be somewhat systematic. So when P is plus or minus 1. P over Q. Can be plus or minus 1 over 1. Plus or minus 1 over 2. Plus or minus 1 over 4. Or plus or minus 1 over 8. Where we would just simplify this to just being plus or minus 1. We wouldn't leave it as 1 over 1. When P is plus or minus 2, I'll change colors here. Plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 2 over 4, plus or minus 2 over 8. Write them all out and then simplify them. This is plus or minus 2, plus or minus 1. 2 over 4 reduces to 1 over 2, and 2 over 8 reduces to 1 over 4. And when P is plus or minus 4, plus or minus 4 over 1, plus or minus 4 over 2, plus or minus 4 over 4, plus or minus 4 over 8. And when we simplify these, we get this. Now, if I want to do some master set. Total options. We don't need to do anything that repeats. So we've got the plus or minus 4, plus or minus 2, plus or minus 1, plus or minus 1/2. From that one. What's the only new addition in this one? 1 over 4, we gotta add that in. What about up here? 1 over 8. Gotta take that one in. So that's a good way to write them, or you could might write them in value order. There's some value to doing this, as you'll see in a little bit. There's a lot of options here, right? So let me introduce you to a couple other rules that can help speed this up. So Descartes rule, or Descartes, what's it called? Descartes rule of science. We're going to solve this problem, but we're going to do Descartes rule of science first. So total number of positive answers. equals the number of sign changes in f of x. Well, or reduced by an even number. This makes up for complex conjugates. Complex conjugates don't count as a positive number and they go out in pairs. So if you have complex conjugates, it could eat up two of them. That's the first half of Descartes' rule of sign changes. And total number of negative solutions. Is the sign flips. F of negative x. You write f of x. Again. So I've got a positive, negative, negative, positive, positive. Looking at the coefficients. There's a sign change here and a sign change here. Two positive roots. F negative x.
I have a question.
Yeah,
Did you mean to put a positive under the 4 or is it negative?
I have to put a positive. Good call. That's why I don't have a sign flip there. Ah. I don't know what the fuck I'm doing. Just over here, just drawing signs. When you take a negative number to an even power, the negative just goes away. This is 8x to the 4th. And on the negative one, the negative stays, so this negative will come out and hit the 26. Here, it's got an even power, so the negative goes away, the sign stays the same. Here, it's got an odd power, so the negative comes out and makes that negative. So that's f of negative x. And we look for sign flips here. And it goes positive, positive, negative, negative, positive. We've got one here, two negative roots as well.
Isn't it positive 27x to x squared?
No. Negative x gets squared becomes positive x squared. And it was already negative. Only the odd ones change signs. Negative x squared is negative x times negative x. And you count the number of odd signs, there's 2, so that becomes positive x squared. Does that make sense?
Yeah.
Okay. And there's another theorem called number of zeros theorem. I think I've mentioned this before. A polynomial of degree n has at most n unique zeros. Sometimes a lot less. Sometimes none. So this is a 4th degree polynomial at most 4 zeros. No yawning.
You'd say it had 4 zeros because that's 2 positive roots and 2 negative roots.
And that's 4, right? Yeah. And now it may not, they may have 0, they might have conjugate roots, but there's going to be roots. So if this doesn't actually speed it up, there's gonna be, of this list up here. We were doing this for this function, 2 of them will be negative, 2 of them will be positive. There's a couple more rules that help. And keeping track of them all could be a pain in the ass, but with practice you get there, and I figured, let's just talk about what they are. That way we can utilize them all at once while we're going. Does anyone need more from this page? This is your chanceless way to tell me that you need it longer.
Most. Yeah, I'm fine.
Okay. There's another theorem called the intermediate value theorem. This is just a lot. It's a very popular theorem. It goes by IDT. And there is one requirement of this thing. F of x has only real coefficients. This doesn't work with complex number coefficients. If f of A and f of B have opposite signs. There's a zero between them. Between A and B. We'll show both setups. Could have it. We'll do like A2 and B2 right here. Could have a dot down here and a dot up there. So like this is f of A and this is f of B, the y value. Y value is greater than 0 up here, y value is less than 0 down here. We don't know where it crosses, but it's got to cross somewhere. So positive on this one, negative on that one. Or it could be like this, where f of A is negative. F of B is positive. But it's still got to cross somewhere. It's got to cross the x-axis somewhere. How can this help us find rational zeros? Yeah. How could, like, if for what we had up here with 8x to the, because these were the rational possible zeros. How could we utilize this theorem to actually make it our problem, like looking for our answers a little bit easier? If we plug in two numbers and they're opposite signs, there's got to be a zero between them. It may not be rational. So, like, don't do 1/4 and 1/2. Skip numbers when you're doing them. Do like 1/4 and like 1. And if they're opposite signs, then there's a zero between them, and it might be 1/2. Does that make sense? If we stick in f of 1/8, if we stick in 1/8 and it's negative, and we stick in f of 1 and it's positive, 1/4 or 1/2 might be a zero because these two change signs. Now it may not be, it may be some square root number. I'm gonna do nothing but this stuff in 3:35 on Wednesday. I'm gonna go over this shit for an hour. We're gonna do examples with this. There's one more theorem. So this is called the bounded theorem, boundedness theorem. And recall we're doing like, is x equal k a 0? So the way the boundness theorem helps is if k is greater than 0 and synthetic division has all positive numbers, there's no root greater than k. So how's this help? Like I had this list of numbers up here. Let's say I plug in 1/4. And the bottom row on synthetic division is all positive numbers. It means I can cross off 1/2, 1, 2, and 4 as possible answers. They're all gone. So if you pick a number and it's got a bottom row of all positives, everything after it's dead. If k is less than 0, like if you're testing a negative number, and the bottom row changes signs, and the bottom row alternates, plus minus plus minus plus minus. There is no 0 less than k. And 0 is considered, for this case, for this scenario, 0 is considered positive or negative as needed to make this rule work. So if you have a plus, a 0, a plus, 0 counts as a negative. There's a lot of fucking rules. These theorems pop up throughout 3.3 and 3.4. So this hasn't all been one section. They kind of do like this rational zeros theorem in like section 3, but like the intermediate value theorem and boundness theorem actually help like narrow down the list of things you have to check on rational zeros theorem, and they don't do it till the next chapter or the next section. I'm like, fuck all that. We're gonna do it together and we're gonna use that. Like I want you to use them as tools. This last one says, like, if I plug in -1/4 and my bottom row changes signs, then I can cross off -1/2, -1, -2, -4. So anything I can do to eliminate possible roots narrows down how many I have to check. Does that make sense? Eliminate as many as we possibly fucking can. So let's put all this together. Let's look at our Josue, are you good?
Yeah, I'm good.
Let's put this all together we had f of x,
Okay.
8x to the fourth minus 26x cubed. And our p's over q's are right here, and I'm gonna list them in numerical order so that I can take advantages of those theorems. That's a big sigh you got there.
Well, right.
So I hate doing the fractions, so like, let's avoid the fractions to start with. Let's try, I'm gonna go with -1. So try x equals -1. Really? I had that listed as not a root. Ah! It's jumped in the fucking answer. Huh. All right, so that's one of them. I don't know, let's try one then. And this tells me if I add 1 to both sides, x plus 1 equals 0, this is one of the factors. And this would be 8x cubed minus 34x squared plus 7x plus 4. I can actually use the one where I have a 0 as remainder right away. I don't need to, I can use the shorter form here. 8, -34, 7, and 4. Once you have one of the zeros, you can keep going down. Once you get it down to an x squared, factoring the normal way is easier. So try x equals 1. That didn't work. Try x equals 4. Let me cross it off as I go. Well, well, well.
We, Using 26, 27, 4, 34, 7, 4.
Once you get one of them, it should work on either one.
Four.
A zero should get, you should get the same thing either way for the remainder.
Okay.
So like, I just got 0 here. Notice if I tried 4 in the original one. I get a 0 there as well. So like, you can use either one. It looks like x equals 4 is a valid one. And so if I subtract 4 from both sides, x minus 4 is one of the factors. But I'm gonna use this one because now I'm down to 8x squared minus 2x minus 1 equals 0. And you could probably go with like, use the quadratic formula to speed up at this point. Once you get it down to an x squared, why keep doing this thing? +2 plus or minus b squared is -2 squared minus 4 times 8 times -1 all over 2 times 8. This is 4 plus 32 square root of 36 over 16. 2 plus or minus 6 over 16. Which is 8 over 16 or -4 over 16. So we get a 1/2 or a -1/4. That's a lot to process. Yeah. And I got lucky. I only had one bad number in here, the x equals 1. Let's be honest though, a lot of this paper is taken up doing multiplication and addition. The hardest math in here on this piece of paper is fucking 4th grade level math. Just the format is a little different using the box and stuff, but you're just doing multiplying and you're just doing adding. Theoretically, you learned how to do all that stuff by 4th or 5th grade. So how does that all wrap up? We had x equals 1 is the solution. Nope, x equals -1. X equals 4, x equals 1/2, x equals -1/4. So if I solve each of these, get a 0 on one side, this is x plus 1 equals 0. This is x minus 4 equals 0. Here I would do clear the fractions first. Then subtract 1 from both sides, I get 2x minus 1 equals 0. And here I would multiply both sides by 4 and I would get 4x equals -1. Add 1 to both sides and I get 4x plus 1 equals 0. F of x equals 8x to the 4th minus 26x cubed minus 27x squared plus 11x plus 4 factors into x plus 1 x minus 4, 2x minus 1, 4x plus 1. We found all the factors. And we found everywhere the graph crosses the y-axis. Or x-axis. But
It's just amazing how it's just. Yeah.
oh yeah, I told you, when I started rational zeros, I said you're not gonna like it.
No, I think it's pretty cool.
It's helpful. We just factored something, we just factored a fucking 4th degree thing. We never learned how to do shit like that. The best we had was cubic, and that required a cubed minus b cubed. Or a cubed plus b cubed. Any other fucking cubic, we were fucked on. All we had really good stuff for was quadratic, really, because we had the quadratic formula. Now, we got some tools to at least find rational. Now, if x equals square root of 3 is a 0, this isn't gonna find it. It only finds rational ones. But you'll learn ways in calculus to find those. Or if you get down to here, you might find them when you get it down to a quadratic formula. If there's only like a couple irrational roots, you can find them here, but otherwise, if like all irrational roots, there's like 8 of them. That's some fucking calculus level shit right there. But you're not gonna have anything like that on the test. I will do more of these in Math 335 on Wednesday, and of course, if you don't show up, you can watch them on the video. We'll do a little bit more of this in class on Wednesday. I just said Wednesday and fucking.
Okay.
And we'll talk about using this stuff for graphing. Have a good evening. Enjoy your fucking happy Halloween. Don't steal candy from little fucking kids. Don't be that guy or girl.
No promise.
Hannah, no walk in the neighborhood and beating up children and taking their fucking candy. I know you're from Texas and all, and you like to, do shit rough, but no mugging children. Unless they look like they fucking go to high school, like they're wearing their football jersey and they're still fucking trick-or-treating, take their asses out and take their fucking candy. Because they're too old to be fucking trick-or-treating. Have a good day.
Have a good day.
Will you be in Mesa on Friday and Saturday?
I will be, yes. I was not there this last Friday. There's work being done on my house and they stayed late, so I missed all my classes on Friday because of it. But I was there this last Saturday and I'll be there both this Friday and this Saturday.
Okay, thank you.
Uh-huh.
I know it's great. Oh, wait. You just for food now? I think they're about to be a little bit ahead.
Stop recording.
Yeah, 6 months. It's crazy.